Now we're going to work with the builder design pattern, and this design pattern is somewhat similar to the template design pattern which you just saw. In the template design pattern, you have a base class which is inherited by inheriting classes. In this base class, you define a template method. In this case, in our examples, we were just calling that template method go, and we had inside the go method a sequence of methods being called, and that was, in the case of our example, we are creating a robot, and we had a start method, get parts, assemble method, test method, stop methods, and so the template method called a sequence of methods, as you see here, and the inheriting class didn't have any opportunity to change that sequence. That sequence was immutable, unless of course you put in hooks, but that's a relatively minor modification. And the only way that the inheriting class could alter that was to override those methods. For example, the get parts, the assemble, the test methods, as you see here, are overridable, so that the inheriting class can implement its own methods. And although it couldn't alter the sequence or the number of calls inside the sequence, it could override and customize what actually happened in each step of the sequence. The builder design pattern is a little different. Here your client code can call a method called add start, add test, add assemble, add stop. So the client code can construct its own robot in this case, and it's going to be able to describe the sequence in which the actions are undertaken. And so, for example, you can add start. We'll create a robot that has a start method first, and then add test. We'll test the product under construction next, and add assemble, add stop, and so forth. So now you're able to actually describe the steps in which the robot will execute its actions. So you're able to, by calling these various add methods, construct your own sequence, and not only the order of the steps, but also the number of steps, and that's the builder template. So you have add start, add test, add assemble, add stop. So the idea is your client code is going to interact with for example, a cookie robot builder. This cookie robot builder builds cookie robots, and you say add start, add test, add assemble, add stop, and you call those methods inside the cookie robot builder. Then the cookie robot that's created by this builder is going to have the start method first, the test method second, the assemble method third, the stop method fourth. So that's how it works with the builder template. You have the client code calls add start to add a start method call to the sequence inside the cookie robot, and this add start method is a method of the cookie robot builder. Then add test adds a test call to the sequence of the cookie robot, and then add assemble adds an assemble call to the cookie robot, and so forth. Now you're able to order the steps in which you order the method calls in which you want to install inside the cookie robot. And when you're done creating the cookie robot with a start method and then a test method call and then assemble method call, a stop method call, you can call get robot on the cookie robot builder object, and that will return to you a robot object the way you've configured it, with the start method first, then the test, the assemble, and the stop method next. And if you want to, of course, create a different type of robot, you need a different type of robot builder. For example, if you want to create an automotive robot, you use an automotive robot builder, and you say add start, add test, add assemble, add stop. This configures the order and the number of steps you want to create in the automotive robot. Add start, test, assemble, stop, and then the end you say get robot, and the robot is returned to you from the automotive robot builder. So depending on what robot builder you use is going to create various different types of robots, and you are allowed, using this design pattern, to configure the steps that the robot will undertake. For example, here it's start first, and then test, and then assemble, and then stop. And since this is under the control of the client code, you're allowed to set the order and the number of steps the robot will undertake, and it all depends on working with a robot builder in this case. So we'll take a look now at using this in code and being able to completely configure the robots we create by working with this in code next, and to see how this works in actual Java.